Unit 5A, Lesson 4, Compare Properties of Functions. This lesson is going to be an extension of the previous lesson. We're going to look at functions in standard form, vertex form, look at the graphs, and then just compare the maximums or the minimums, various things with these functions to answer questions. Now to the first example, the graph representing a function is shown below. Which function has a minimum that is less than the one shown in the graph? So first we have to find the minimum of the graph. That is -1, 2, 3, 4, 5, 6, -7. The minimum refers to the y value that is the minimum, which is -7, that occurs at an x value of 3. So we have to take each of these functions, find out which one has a minimum less than that. The first equation is in standard form. So if we have a quadratic in standard form, we talked about this a long time ago, we have an expression x equals -b over 2 times a. That gives us the x-coordinate of the vertex in standard form. So I would take the opposite of -6, which is +6. 6 divided by 2 times 1. 6 divided by 2 is 3. So for my first equation, I'm going to plug 3 in for x. I get 3 squared minus 6 times 3, and then I'm going to add 7 to that. 3 squared is 9 minus 18. 9 minus 18, -9 plus 7, -2. That is the minimum for equation 1. Then I go to equation 2. This is an absolute value function. We talked about that earlier in the year. We can quickly identify the vertex. The vertex in this case is going to be a minimum because my a value is 1, which is positive. So this vertex is going to be -3, -6. Has a minimum of -6, which is not less than -7. So now I go to the third equation. That's just like the first one. It's in standard form. The opposite of -2 is going to be a +2. 2 divided by 2 times 1, which is 2. 2 divided by 2 is 1. So I plug 1 in for my x values. So I have 1 squared minus 2 times 1 minus 10. 1 squared is 1 minus 2, -1 minus 10, -11. So equation 3 is going to have a minimum that is less than the one shown in the graph. If we just went through number 4 quick, that would have a vertex at 8 and 2. So that would only have a minimum value of 2. It would open up because our a value is positive. So when we have a quadratic in standard form, like we did in equations 1 and 3, we have to use the expression -b over 2 times a. This gives us the x-coordinate of the vertex. Then we can plug that x value into the equation to find the y value, which is going to be the minimum or the maximum, depending on our particular equation, the a value in that equation. Now to example 2, which function has the greatest y-intercept? So in the first equation, we have f of x equals 3x. We can just relate this to y equals mx plus b, where b is our y-intercept. There's no value added at the end, so that implies our y-intercept is 0. Equation 2, this is in general or standard form. We can use the cover-up method. If I ignore my x term because I'm just looking for the y-intercept, to get y isolated by itself, I divide by 3. So I know my y-intercept in this case has to be 4. Now to the third one, the line has a slope of 2 and passes through 1, -4. So we have to use y minus y1 equal to m times the quantity x minus x sub 1. This is our point slope form. I have my x sub 1 and y sub 1, and I have my m value. So I have y minus a -4 is y plus 4 equal to, I have a slope of 2 times x minus 1. Now simplifying this right side, I have 2x minus 2, so y plus 4 is equal to 2x minus 2. Next step would be subtract 4 to the other side. So y equals 2x minus 6. So this one has a y-intercept of -6. So far that is the least, but we're not looking for the least this time, we're looking for the greatest. So then we go to the fourth one, which is the graph. We identify the y-intercept where it crosses the y-axis, 1, 2, 3, 4. This has a y-intercept of 5. So which function has the greatest y-intercept? It's going to be the fourth one, the graph, where it has a y-intercept of 5. The equation of this line would be, we have a slope of 3. If I pick a point, up 1, 2, 3 over 1. So this would be the equation y equals 3x plus 5. Now to the last example. The functions f of x, q of x, and p of x are shown below. F of x is the graph. We can see our y and the x-intercepts. We can find the equation. We have q of x is equal to x minus 1 quantity squared minus 6. So it's a quadratic equation in vertex form. And then we have a table of values. We have our inputs, our x values, and the corresponding outputs, the y values, which p of x represents the y values. So when the input is 4, which functions have the same output value? So when the input is 4, which functions have the same y value at that point? So first I'm going to start with f of x. When my x value, which is my input, is 4, 1, 2, 3, 4, I go up on my graph, my y value is going to be 3. Because I'm looking at this point. X value is 4, y value is 3. Now I go to q of x. This gives me the equation, so I'm going to plug 4 in for x. So 4 minus 1 is 3. So I have 3 squared minus 6. 3 squared is 9. 9 minus 6, that gets me 3 as well. So right away I know f of x and q of x have the same output value for an input of 4. Then I go to the table of values. When my x value is 4, my input or my output value is 3. Input is 4, output is 3. So for each of these functions, when the input value, the x value is 4, the output, the y value, the function value is 3. So the correct response would be 4. F of x, q of x, and p of x, all of those have the same output value for the input of 4.